Good morning, children. Hope everyone are fine. In last class, we have discussed about the introduction of laws of motion. Do you know who proposed these laws? The Sir Isaac Newton proposed these laws. So, these laws are also known as Newton laws of motion. Okay. Today class, we will be learning about the first law of motion. Totally, we will be having 3 laws of motion. So today we will be learning first law of motion. So now to discuss about the first law of motion, first we will be understanding of the rest of an object and motion of the object. Already we have discussed in the first lesson. In the motion, yes or no? So if the object is the rest until and unless we apply some amount of the force, then only it moves. If it is moving, continuously moves. If some force is exerting in order to stop, yes or no? Yes. Based upon the rest and the motion, the first law is based. Means every object remains the rest until some amount of force is acting. If the object is moving in uniform motion continuously, when does it stop? When we apply some amount of force. So here, the first law will be explaining about when no net force acts upon a body. Means if it is the rest, no force acting, net force will be 0. If it is moving uniformly, where the no net force is 0. Okay, let us see. When we see here, observing the activity. Okay, observing the motion of pen cap kept on a thin paper ring. Here, children, the first law I wanted to the state of the rest and state of motion. Okay, you remember that one. So let us take here. Let us take one thin paper. Let us make a circle like this. Okay, take one bottle within a hook. Okay, and a pen cap. Okay, you make the bottle stand on the floor. On that, let us keep in a paper hook on that pen cap. Okay, it will be like that. Make that it should be straight. It is in the rest position. When does it move? When we apply some force, what happens? It will be moving. Yes or no? When we take out this paper hook, what happens? The cap will be ultimately falling into a bottle. Means in the first case, what happens? All the objects are in the rest position. Until and unless we apply some force, it moves. So this explains the first law. Another activity we can see. The caroms. How will be arranging when we are playing the caroms? We'll be arranging one side the white coins and other side the black coins. When we hit at the bottom like this, what happens? Only the bottom will be moved off. If the force is more, what happens? The upper coins also will be falling down. Means here the force which is applied to a coin is acting in order to move or in order to stop. So until and unless some force is acting only, the object is moving. And same activity we can see when the books are arranged in the bookshelf. If you want to take only the one book from the bottom, what will be doing? We'll be taking. The remaining will be rest. Means the force which is applied to one object and then only it will be moving. Okay, so here the body will be the rest until some force is acting, and if it is continuously moving, some force will be acting, then only it will be stopping. So here the body which is in the rest position, where it does not accept any change in the position until some force is acting, that property we will be calling as a static inertia. For example, I kept the pen here. Means it is having the static inertia. Means until unless I am applying the force in order to move. Okay. So with first position, initial position, we call this one as a static inertia. When it is moving, means the static inertia, when does it move? When we apply some force like this, it moves. So the movement of the object here, we call this one dynamic inertia. What is that one? Dynamic inertia. Another example we can see. Okay, it already is there on the top. An object is kept. It is the rest position. When we pull like this, what happens? First is in the static inertia. When we pull, what happens? It moves to a dynamic inertia. So here, how can we define the dynamic inertia? Is the body which is in motion always try to move in the same direction until some force act on it. So this property is called as what? Dynamic inertia. Means the pen is there. I move like this. So from this position I move like this. So it went, and due to friction here it stopped. This is called as a dynamic inertia. So here children, any object on the earth will be applying all the types of, as we have learned in the free body diagrams. As on all the force will be acting like gravitational force, normal force, force applied by us, and frictional force. So based upon them, here the force are acting, and where the first law is applied about the motion or the rest position. So is there any relation between the mass and inertia? Let us see what's the relation between the mass and inertia. Before that one, a small example. A ball is kept on the floor. It will be the rest. Here what property is acting? Static inertia. When we hit that one, it moves continuously, and until unless the friction force act upon it, it comes to the rest. Means when it is in the rest position, the pen is in the rest position here. Here the F net is equal to 0. The net force acting upon it is 0. When it moves like this, okay, it moves far distance. Here the uniform motion. Depending upon, it moves continuously until the friction is acting. So that time what happened? The velocity will be 0 or constant. Then only it moves in uniform motion. Okay, this property of telling about the rest and motion of an object, okay, we call that one as an net force. First law of motion. Okay, when the net force is acting on an object, if it is in the motion or in the rest position, the net force is 0. We call that as Newton's first law of motion, or we call the Newton first law of motion as also law of inertia. So let us see the difference between the inertia and mass. Inertia and mass. So a small example we will be taking car and bicycle. Car and bicycle. Which one can be moved? Which can we move? We can move is bicycle than the car, because the bicycle is having what? Less energy, whereas for a car more energy. So about this, so it depends upon the inertia. Okay, so this is how, means if there is more mass, more inertia. Okay, understood? If there is less mass, less inertia. So same as like this, you can take the example of a two wooden box. So which one is having more inertia? Which is having more energy, more mass? They will be having a what? More inertia. So both mass and inertia are both related objects. The mass is a property of an object which specifies how much inertia is the object is having. Okay, so these are the two properties, and we know that the mass of an object is determined by using the property as a unit of the mass is kg. Okay children, this is about the first law, and then for the next class we'll be seeing about a second law. Okay everyone, write the important points in your notebook, because one day we'll be calling for you to notes correction, as well as here the for 8th and 9th the class are going. Remember that. Okay, so very important to attend the classes, not only the video classes. If you attend the regular classes, this is very good, and we can complete the syllabus. Okay children, note the important points in your notebook. Thank you.